All right, you guys all have your notes there, right?
Yeah.
Okay. Hey, a couple things I want to go ahead and start just reviewing. Throw you maybe a couple questions your way. We'll see if we can't tie all this together to figure out what the heck we're doing. Obviously, the notes are only 2 pages long. It's pretty short, really, right? Okay. Hey, up here, real quickly, a couple things to recall. If you're ever dealing with a proportion, say maybe 3/8 equals maybe, oh, I don't know, how about 18 over x, okay? Not too concerned about the answer right off the bat, but how about you guys remind me the process of working with this to solve for an unknown? All right, Brandon, what do you think, kiddo?
8 times 18 divided by 3.
So I'm going to cross multiply 8 and 18 and then divide that value by 3. Okay, so how about a volunteer to carry that out for me? 8 times 18 and then divide that answer by 3. I'll try and beat you.
18 times 8. That is 48.
48, very good.
Thanks,
Okay.
Chelsea. You always said it.
48.
Well, we said it together.
All you guys agree 8 times 18 and then divide by 3? All right, so we understand proportions, right? Okay, so I understand proportions. Okay, let me do this real quickly then. Next thing I want you to recall is this. What if I threw a shape up here that looked like, oh, I don't know, this. There it is. And I do this. I call this shape right here A, B, C, D. First of all, what's true about these two shapes, the way they look? They're the same. So we just got done dealing with a section involving similarity and congruence. Are they similar or congruent? What makes them congruent? Be careful. Same size, same shape. So the size is important, right? Okay. I'm going to call this WX, Y, and Z. So guys, if I told you right here that this was 12 and maybe this up here was, I don't know, 70 degrees, what other two values do you know? Or in other words, what angles or sides would you know in one of the other figures? Knowing that those two shapes are congruent. What's one of them, Seth?
Y is 70 degrees.
Okay, you're saying angle Y right down here would have to be 70 degrees. How about your justification for that?
So they're the same shape.
The same shape. And what are you thinking about angle Y? What did that match in the other figure? Y and C correspond to each other, right? They're corresponding parts. Therefore, if C was 70 degrees, thank you, Scott. If C was 70 degrees up here, what would that mean about this angle? Had to be 70 as well. Okay, good. Brandon, what else do you know?
A and D would be 12.
Okay, the distance from A to D is 12. And how about your reasoning there?
Because W and Z equal
Okay.
inside.
So if I understand you correctly, it sounds like you're saying, well, AD corresponds to WZ. Those two sides would match, right? Therefore, the term corresponding. And that means that if WZ is 12, then if these are congruent, that makes the distance from A to D 12. Okay? So this is all stuff that we looked at in the last section, right? Okay. Here's what I want to throw out at you. I want to see if you can figure some of this stuff out. I'm going to go away from the congruence, where the sizes are the
Same.
and I'm going to jump back to similarity, where the shapes will be the same, but now the sizes will differ. Okay? Hey, listen to this real quickly. You guys remember that day I got kind of crazy and I said angles are, anybody remember the word? And sides are, angles are equal. Remember that? Angles are equal. Sides are
Same.
no.
Different.
Whoa! Somebody said. I heard it. It's the P word.
I'll see.
Sides are what? I can't hear you.
Proportional.
I can't hear you.
I'm not yelling it.
Proportional.
Proportional.
You're welcome.
I'm not.
Sides are proportional. You bet. Guys, we got into this idea about, we start talking about anything with, anything involving similarity or congruence. We said, you know what? Corresponding angles will always be equal. Corresponding sides will always be proportional. All right? By the way, if I went back to the congruent right here, congruent one, what's 12 over 12 going to be for a ratio when you simplify it? What would 12 to 12 be? 1 to 1. 1 to 1 simply means they're the same size, right? It's a 1 to 1 ratio, okay? 1 to 1 ratio. So if everything's ever, if something's ever a 1 to 1 ratio, are they similar or are they congruent? Congruent, they'd be the same one, right? 1 to 1. All right, let's talk about this idea of similarity. Let me draw the best I can a shape. Okay, pretty good. Pretty good. Not bad. Not too bad. Not too bad. Nope, not bad at all.
Why are you making it thicker? Oh, never mind.
Okay. Oh, let's go crazy. Letters A, B, C, D, and we'll go R, S, T, and U. Don't need to write any of this down just yet. Don't need to write any of this down just yet. I'm going to throw some angles up in here. I'm going to say that angle R is 70 degrees. I'm going to say that angle B is 110 degrees. I'm going to tell you right here that A to D is 7. I'm going to tell you that the distance from R to U is 21. I will also tell you that the distance from R to S up here is going to be 33. Okay. Change the colors and see if we can't figure some stuff out. Any kind of similar or congruent figures, you ought to understand that corresponding angles will always be equal, right? Right?
Yes.
And anytime we're talking about corresponding sides, they are going to be proportional. Proportional meaning the same ratio. Okay? Just kind of talking about things up here. Are there unknown parts up here that you could identify with the information that's given up here? In other words, you might say angle D is blah, 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 or angle T is blah, 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 or side ST is blah, blah, blah.
Blah, blah, blah.
Random first observation, what do you think?
Angle S would be 110.
Angle S would be 110, all right? Argue, buddy. Tell me why.
Because the angle is the same as
Okay, so the angles are going to stay congruent. So you're telling me that angle S is how many degrees?
110.
Where are you getting that 110 value from?
Angle B.
Angle B. So if I understand what I think I understand, you're saying that, but this isn't. I gotta do it front, don't I? You're saying angle B is corresponding to angle S, right? And if angles are going to be, or I should say corresponding angles are going to be equal, it's no BS that S would be 110, right? I love it. How many agree with Brandon's argument? No BS, angle S is 110 degrees. All y'all? All right. So I've used all you all, and I've got a Daytona 500 countdown. I get a big yeehaw from everybody. Yeah. All right. What else do you know? Or what else do you think you could figure out? Someone besides Brandon. Brandon, thank you, but what else do you know?
What about angle AB, or segment AB? Side AB.
Thoughts, Chelsea? Huh? Okay, let me come back to you. Why do you think 33, first of all? Matches RS, but are we talking about the same size, or are we talking about a different size now? Let me underline a couple things for you. Degree 7 and 21 correspond to each other, first of all? Like the same parts of those parallelograms? Are 7 and 21 the same exact distance? Which would indicate one's bigger than the other, right? By what factor is the parallelogram on the right bigger than the one on the left? In other words, what would you do to the 7 and the 21? Could be a fraction. I think of it as this. If I'm going from 7 to 21, what do you have to multiply the 7 by to get to 21? Well, what do you have to divide 21 by to get back to 7? 3. If I'm going this way, times by 3, right? Or if I was going backwards this way, to go from 21 to 7, you would divide by 3, right? So if I'm going from a bigger value to a smaller value, you would divide. Or if I'm going from a small value to a big value, you would multiply, right? Chelsea, got other thoughts on AB? Why 11? Yep, I could say, well, 11 times the 3, or the same factor right here, would be the value to multiply by 3 to get to 33. Now, I want to show you this right here. When we say sides are proportional, check this out. You guys agree that 11 and 33 correspond to each other? Everybody agree 11 and 33 correspond to each other? I'm going to write that fraction right down. 11 corresponds to 33 as, what did the 7 correspond to here? What did 7 correspond to? 21. So I'm going to say 11 is to 33 as 7 is to 21. Now, a couple ways to think about this, gang. First of all, what's 11 over 33 going to reduce to? What's its simplest form in fraction form? 1 over 3, right? So this simplifies to 1/3. How about 7 over 21? What's that reduced to? 1 over 3, right? Ratio's the same? When ratios are the same, what's that mean right here? Are my side ratios, or are my sides proportional then, according to what this definition implies? It is. Okay, so another thing I could have done, so I don't know, but do this one. Who's got 33 times 7 for me? Anybody know it?
33 times 7, you said?
Yep. Hopefully, come up with 231.
231.
John, do 21 times 11.
21.
200 and?
231.
Cross products are proportional, right? Okay. Here's what I'm getting at today.
Exactly right, Mr. Person.
Sides are proportional. Okay, so I would say 7 is to 21 as 11 is to what here? Okay, listen to what I said. 7 is to 21, small value to big value, corresponding parts, as 11 is to 33. Again, small value to big value, corresponding parts, right? By the way, one thing that we didn't get in this, do we know angle A?
Yes.
How many degrees?
7.
7. Okay. Keep this in the back of your mind right now. Let's head over to the notes. Any questions about what I kind of discussed here when we explored this here? Guys, really, everything that you need to know is right in this example. You pretty much told me what to do. Okay? So, let's take a look at the notes quickly. Page 1 here. Guys, similarity and measurement. Here's the dealio, guys. Today, we're going to leave the congruent part out of this. We're talking about all similarity now. Okay? Just similarity. So, keep this in mind, okay? We're talking about the same shape, but how about our sizes today? One's going to be bigger than the other, okay? So goal-wise. Goal-wise, we're trying to find unknown, what's the phrase right there? Unknown side lengths of similar figures. This is how you do it. This is how we do it. Okay.
Unknown side side length you said?
Finding an unknown side length in similar figures. Here's how this is going to work. Okay? It says given figure RSTV is similar, same shape, different, size, to WXYZ. We got to find the distance from where to where here, guys. V to what?
R.
Okay. Now here's the deal. I always look at the figure on the left and go to the right. Okay? So here's what I'm going to do. V to R is labeled as what, guys?
X.
X. What would this X really correspond to right here? Let me zoom up on this. What would this X really correspond to in this example, guys? X would correspond to 15. Okay? Then, are there other side lengths right here? Are there other side lengths, one in the bigger figure, one in the smaller figure, that you know the lengths of that correspond to each other? Well, what's the only other length that you know over here? 14. What's this 14 correspond to over here? Listen to what I say. Do you guys agree that to find a distance VR, they labeled it X right here? We don't know what that distance is, right? It's unknown. But what I would do is I would say this distance X is to 15 as the 14 would be to 10. Guys, listen to this. If I set one ratio up by starting with the figure on the left, the second ratio has to be set up by starting with the figure on the left. Always start on the same figure with each ratio. So here's what my proportion is going to look like. I would say this distance X, whoops, there we go. This distance X is to as, when I use the word as, what am I going to throw in the middle? Okay, what's the other ratio I would set up with the given information in there?
14 over 10.
Why not 10 over 14?
Because it's 14 to the same one as X.
I started with the figure on the left, put it up top, so the figure on the left, keep that 14 also on the top of the second ratio. Okay. Gosh, you know how to solve those now, don't you? What is 15 times 14? Anybody? 200 and? Yeah, right. 210. Take 210 divided by 10. What's your value? 21. Now, guys, I don't know about you. But first of all, do you understand my explanation?
Yes.
The distance from V to R is 21. Okay? They give you everything that you need to know right over here if you want to read through that. But I like what I did. Circle stuff. This is to this as this is to this, right? By the way, do they get 210 in their notes? And then divide that by 10 to get a value of 21 right there? Okay. So, here's what I want to do. Let's talk about this one down here. I can kind of see this. I'm going to zoom up a little bit. I apologize for the quality of this.
It's amazing.
Two things about this. Somebody said that to me first.
This person?
Yeah. Did you have a question?
Yes.
Okay.
Oh, never mind. Sorry. I thought you said that we were supposed to ask you a question.
Oh, no worries. It's all good.
Okay, thank you.
All right, this one here is maybe a little bit more difficult because if I go back up to the original example right here, you're going to hear me start talking about the word, and hear this quick, with orientation. Okay? When I talk about orientation being the same and orientation being different, it's kind of the way they're set up. Guys, this is a pretty nice visual to look at. It's pretty easy to say it. You know what? R would match angle what here? And it would be easy to look and say, well, S matches X. Okay? Let's see what it is. T is going to match what? And V to... That's easy to see, isn't it? Because they both kind of lie in the same general position. I would say the orientation is the same. But now, what would happen if I would take this and maybe turn it like half a turn? Doesn't that kind of mix things up or make it more difficult?
Yes.
Well, isn't that what's going on down here? With these triangles right here that you have in your notes, does the orientation of each triangle appear to be the same, or are they different?
Different.
They're different, okay? This is what I want to get back to about this example. Stuff that's very important. What's it say to find first? Find T to S. Okay, T to S. They labeled T to S as the letter what?
X.
X. Okay, we got to figure out what T to S corresponds to in the other figure. So watch what I do. I'm going to go back over here. We said, you know what? The stuff that's given right here is very, very, very important. Right up in here, T to S. How is T to S listed in the given information up here? 1, 2, or 3. So it looks like T and S is the second and the what?
Third.
Second and third vertices listed in that order, right? Well, doesn't it have to match the second and third vertice in triangle PQR? What is the second and third vertice? So do you guys agree that this TS right here has to correspond to the side QR? Everybody agree with that?
Yeah.
Okay. So that means this. It means that, you know what? The two sides I've labeled in red have to correspond. So I'm going to say X is to 12. And obviously, what's your other one right here, guys? Your distance from S to V is 10, isn't it?
Yeah.
Well, SV right here is the third and the first, so the third and the first up here is RP, and RP right up here is how long? RP is what?
15.
15, right? RP, Richard Petty, Daytona 500. Yeehaw! Right, Slater? Am I going to put 10 over 15 or 15 over 10?
15.
How about you guys help me set a proportion up? Blank is to blank as blank is to blank. X is to 12.
As 10 over.
Does it have to be 10 over 15 if I set X over 12?
Yes.
I got to go, in this case, small to big. So as 10 is to 15. Finding this length, no problem. We're going to go 1.
12 times 120 divided by 15.
What is that? 8. Does that match what they already gave you down here? Do you understand how we set that up? All you're setting up to find unknown size is a what?
Just like the last.
What are two equal ratios called again? Starts with T. Proportions, right? Proportions. Rule. Next page. Everybody have that down? Okay, page 2. Using indirect measurement. Oh, I like talk like this. Okay. They give you a nice diagram. It says a certain time of day, a person who is 6 feet tall casts what? 3-foot shadow. Here it is. There's basically a person standing right here. There's a 6-foot person standing right there. 6 feet tall. That means go up and down, right? Where's your shadow typically at? Okay, from the point where your feet meet the ground, it says the shadow's how long? 3 feet. It says at the same time, a tree casts an 11-foot shadow. Guys, why did they put 11 feet down here on the bottom and not up here? The shadow's going to be on the ground, so it's got to be like a ground distance. That's where that's coming into play. It says how high is the tree then? Well, can't I set a proportion up? Because these triangles will be similar, right? Okay, so help me set a proportion up for this. What is to what as what is to what? Okay, so you start with H, all right? And it doesn't matter. Could I start here and say 6 is to H, go that way? As long as I go the same direction with the other one. So let's do that. We'll say 6 is to H as 3 is to 11. Now, Mason, the way you started saying it, you were going to say H is to 6. If you would have done H over 6, what would you have in second ratio? 11 over 3. Very good. By the way, if the shadow of the tree is bigger than the shadow of the person, what must be true about the height of the tree in relationship to the person? Bigger than 6 or smaller than 6? That'll be bigger. You get something smaller than 6, you'll know, gosh, that doesn't make any gosh darn sense. Okay? It's kind of like when I tell my wife, I don't make trash, I burn it. She says, that ain't making sense. Okay?
Well, your wife?
She tells me I don't make sense a lot.
Does she look almost like you?
What's that?
Does your wife almost look like you?
No, not at all.
That's
Funny
what
story
I-
about my wife. When my wife goes out in public with my kids,
Yeah.
people will ask her if she adopted the kids.
Okay.
Unfortunately for the girls, they all look like me and not her. Okay?
So do they look like you? They're the exact same height you, only they're you with a wig on?
Kind of.
Okay. Just
I think they're pretty cute.
okay.
I always say they look like me, but hopefully they got mom's brains. So. What do you guys get when you solve that?
6 times
Does that match what we have down here, 22 feet tall?
Yes.
Does. How you feeling about this stuff, gang?
Good.
Pretty good? Okay. I think the example I really need to touch on is this one right here then, okay? I'm going to kind of draw this on a different sheet of paper. I want you guys to help me label this. We got to find a distance for what right here, gang? X. All right, this one's kind of difficult. All right, so you might want to put a star by this and write down what I put down on this here. But guys, sometimes you're going to have a smaller triangle within a larger triangle. Okay, you're going to have a smaller triangle within a larger triangle. And this is one that's got to take an extra step to be able to figure it out. And here's how we're going to do this, okay? Here's how we're going to do this. What I'm going to do is this. I'm going to form two triangles, kind of like this. Now, you guys can imagine a line being right in there like it was originally, right? Well, let's just suppose I take this line out. And suppose then that I have maybe the triangle that's on the inside of it right. Oops, I didn't want to do that. I wanted to do it this way. Suppose I have a smaller triangle like it right in here, okay? If you can imagine me taking this triangle right here and kind of slide it up, can you kind of visualize that what I've done is taking this triangle out, which I'll try to make it better. Give me a second. Can you guys imagine me pulling this triangle out now? You see the two of them?
Yep.
Okay, let's do this. Help me label the small one appropriately. Give me the vertices first of all. What's this vertice over here on the left? C. This is the short one. E. D.
Yes.
So this would also be C for the bigger one, and I'm guessing A down here,
Yes.
and up top here a B.
Yes.
Okay. Now guys, watch what I do here. In this right here, we're trying to find this distance of X right here. So I'm really trying to find the distance basically from here to here, right? Would you guys agree with that? You guys agree with that? Okay. So kind of set that off to the side for now. I'm going to pull this triangle back down here, and let's label what we know. Okay. What distances were given to you in those two similar triangles? C to E is how much?
30 inches.
Okay. Any other distances you know?
16 for the bottom.
D to E is 16. Do you know A to B?
B to A.
24. Okay. I'm going to go ahead and do this. I'm going to get rid of this line up here. Now keep in mind, this is the distance I'm trying to find up here, right? What I'm going to do is this. I'm going to try and figure out this whole distance right here. Okay? Because here's what's going to end up happening. I don't know what this distance is, so I'm going to say, well, let's just call it something like y. All right? The distance up there is y. Okay? What would y really correspond to in the big triangle down here in the smaller one? I'm going to say that total distance y is to 30 as 24 is to what? Okay, do this for me. I'm going to say y is to, what again? As
24 is 16.
okay, now I'm going to back up here. Do you guys understand why I pulled that triangle out of there?
Yeah.
So I have how many different triangles? Two. I think it's easier to visualize when I have one separate of the other. Do you guys agree? Okay, when you've got one stuffed up inside the other, that's kind of hard to reason with. So I think it's a good idea if they have stuff inside the other, pull one out, draw your two figures, and label something. All right, so let's cross multiply and divide here and see what we end up with. Do you guys get a value there? Hopefully you end up with
720 for
I'll
30
divide that.
times 24.
45. The distance of 45.
Yep, I got a distance of 45.
Okay, so your y value is 45. All right, so I know what this total distance right up here is 45, right guys?
Yep.
Well, watch what I'm going to do here. I'm going to take this other triangle now and slide it back up in here, knowing that the distance from here to here is 30, right? Isn't this the original x value you wanted to find in there from basically, oh, it would have been E to B? Okay. Well, once I found that total length from C to B of the bigger triangle being 45, is there anything I can choose to do now with some of the dimensions to find that distance of x? Say that again, Mason. Not divided by. If this, okay, if the distance from C to B is totally 45, and from here to here is 30, how much further would you have to go to get to the end? What would you do? Subtract, that'd be the difference. So to find this distance x, you agree that this is 45 right here minus how much? 30. So what's that distance going to be? 15. That distance would be 15, right? Now, does that match what they already indicated in the notes there?
Yes.
Okay. All right, so here's the deal. Anytime you have a shape inside of another, I'd strongly encourage you to redraw it. Label what you know so that you have two shapes. Find that unknown overall length, and then you may have to do some subtracting to find some of the unknowns. Does that make sense? Folks, what questions have you got? Anybody? Going once. Going twice.
So,
All right. Let me finalize this quickly. Any questions?